So, and that's the next thing he talks about. You want the lowest terms representation. So how do you do that? And we're gonna use a method that's already been developed. It's actually a method developed around the 0 BC called Euclid's algorithm, and it basically here's the information on it, but this is how you implement it. So we can just trust it works. Now the way this particular method works is you have to define it outside of your class. So we're going to just copy it. And the book doesn't point that out clearly, but I'm going to define it before I start the fraction class. So basically you give it two, basically a numerator and denominator, and actually it's going to find the common denominator. So you give it two numbers and it's going to find the common denominator. So it's basically, you see there's a loop, and it loops until it has a certain condition, and then finally it returns n, and then you divide n into both parts of the fraction to reduce it. So if you have 6/8, it's going to return 2, and you divide 6 by 2 and 8 by 2 to get the new fraction. So that's how you actually use it. So then when we do our add, after we've done this, we want to actually then pass the, we want to say new fraction, we want to divide this by this number. So let's compute the common denominator, lowest common denominator equals GC greatest common, it's the greatest common denominator, sorry, greatest common denominator is equal to, oh, we can't call it the same thing as a method. We just call x, GCD, new numerator, comma, new denominator. There we are. And so what we're going to do is divide these by x. Now let's mention something here. In old Python, you could just divide by x, but remember these are integers. So if you divide by x, the slash will convert it to a floating point. So we need two slashes. This is actually called true divide. And x. So now when we run it, you'll see it's 3/4. Now in the exercise you're doing, you really need to do this everywhere you create a new fraction. So you're going to move this step where you reduce the fraction to the lowest common denominator, and you're going to move it up to and put it in a knit. So you want to think about that. So whenever you do a knit, the top and bottom, you're going to reduce it just like we did here before you store them in the new object. And then everywhere that we're using GCD, you don't have to do it because it'll happen whenever you create a new fraction. Notice the way it does the add, it's adding two fractions together, creating a new new numerator and denominator, but then it's actually creating a new object and returning the new object. It's not returning some modification of one of the objects on the left or right of the plus. And that's what you'd want. A plus, when you add two numbers together, it doesn't modify the original numbers. So this, you want to create a new number here, a new fraction. Okay. So now, just like you did add, you can do other magic methods. And part of the assignment you're going to do is basically adding all the rest of the magic methods you would want for fractions. So you can do equality, which is equal, testing if two fractions are equal. You can do greater than or less than. There's a whole bunch of magic methods you can do. So the next one we're going to do is equal, which is, this is going to implement equals. So basically we want to get the equal if they're both reduced to the lowest common denominator, then they're equal if the numerators are the same and the denominators are the same. In this code, they don't assume that, so they set the first number to the numerator times the other denominator, and the second number to the numerator times the other denominator. Is that right? Yeah, you see the other and self are different, and then they check if they're the same. So what they're doing here is getting a common base. So basically they're looking at the two numerators with a common base. So you remember the step we did for add up here. So how are they doing equal? They're basically doing this operation and this operation on the two fractions. They have a common base, and once they have a common base, they can just compare AD to CB, and that's what they're doing in the equals. So let's go ahead and implement it. And you notice they're returning a Boolean. It checks, is the first number equal to the second number? And so we add that after this method. And do a little indenting. And this method is not indented very well either. Let's see. I think I have GCD. Okay. Let's run this. Make sure we have no errors. Okay, that seems to be working. So now we know F3 is 3/4. Let's actually print is F3 equal to a new fraction that has 3/4. And that should say true. Oops. It says init missing one required positional bottom. Let's see what happened here. Oh, I said 3/4. We have to say 3 comma because they're separate parameters. And it says true, so it's working. Now in the test code you're going to run, it has a bunch of tests that test if everything's working. So if you actually wanted to test if things are working, instead of just printing out that this is true, you can do a special statement called an assert statement. And the way the assert statement works is you basically have assert, and you can have a message. Let's see, equal magic method seems broken. So you have a message. So what happens here is you can test your code. I create some fractions, I do some math, and then I test is F3 equal to fraction 3/4, and if it is, it's not going to do anything. It skips the assert. But if it isn't, it'll give an error. So let's run it and see what happens. So it should just print true again. Oh, we're not printing anything. So you see nothing happens. But if we change this to expect that it's 1/4, it's going to fail because it's not equal to 1/4. So you get actually an error message, and it says assert F3 equals fraction 1/4 equal magic method seems broken. And then you get an assertion error, and it gives out the message you put in quotes. So if you add these assertions, you can actually build up special code that check out that your code you're writing is correct. This is called testing, and in this case, since we're testing just our class, it's a form of testing called unit testing. If we have time later in the class, we'll show you a more formal way of unit testing using a library that's designed for that, which is very common for a lot of languages now to use the same techniques. Okay, so that's good on that video before we go into some more. So look, we're going to have several videos on classes, and we're also going to show you some extra things that are not in the book on classes.